Okay, Assalamualaikum and good day everyone. Okay, so this video is a special recorded version to give you briefing on task number 1 and also task number 2 for lab 2. Okay, lab 2 electro-hydraulics and electro-pneumatics. All right, so this is actually under part A lah. If you refer to your lab sheet, for part A you have to do simulation tasks, and then for part B you have to do the hands-on part where you have to come to the lab to perform the experiment. But this video, I just want to focus on task number 1 and also task number 2, which are the simulation tasks. All right. Okay, for the exercise, you just have to follow all the instruction. It's just good to have as preparation before you perform the actual task for the simulation. All right, so for task number 1, you are given an application which is an automatic door system for a bus. Okay, so you can read the instruction carefully. Not instruction, you can read the situation. Okay, all this paragraph is actually a situation that contains all the requirements that you have to fulfill in order for you to come out with your own proposed design. Okay, so this type of question we call as a open-ended question. Means we give you a situation, so you have to understand the situation and try to extract as much as information that you can have, which are at the same time the requirements that you have to have in your design. So you can go through this. Okay, you can see figure A illustrate a semi-automatic door system used for the bus. So the figure number 8 is the actual look of the system, where you can see the actual cylinder, pneumatic cylinder attached to this kind of mechanism that will open and close the door of the bus. Okay, so this bus is equipped with, this door system is equipped with electro-pneumatic system. So the figure specifically shows the front door of the bus, which is strictly for passengers entering the bus only. Okay, so this is important. The scope of the project is only focusing on the door for the front part, right? The door is open when the cylinder extends and closed when cylinder retracts. This is exactly what you can see from the actual look here. Okay, when the cylinder extends, the door will open. When the cylinder retract, I hope by now you should already know that extend means this direction, and then retract is means by this direction. Okay, so extend, door open. Maybe you can highlight. Okay, the door open when cylinder extend and close, cylinder retract, because this is very important for you to start drawing your circuit in your proposed design. And this is the figure B is the original pneumatic system that shows you a semi-automatic door. Okay, so this is semi-automatic. So what you have to do as engineer in Rapid Malacca company, you are assigned to upgrade. Okay, you have to upgrade the front door system of the bus. So means instead of semi-automatic, you have to upgrade into fully automatic. Okay, fully automatic means the door should be open only when a sensor detects the presence of passengers outside. Okay, so when there are passengers detected outside the bus, then the door should be open automatically. Okay, so you have term N here. So you have to think of a suitable or an appropriate logic. Okay, logic means either you need to use or you need to use and, or, you know. So So the door should be open first when the sensor detects the presence of passenger, and also when push button is pressed by the driver. So this is for a safety reason. On top of just detecting by the sensor, the driver also have to press the button. So what do you think? What kind of logic you should use? You should know by now, right? And then the door should remain open as long as sensor detects the presence of passengers outside the bus. Okay, this is also another requirement. And then the next requirement is the upgraded system should also come with indicators. Okay, for the passenger to easily be aware that the door is opening or closing. So when we're talking about indicator, it can be what? Okay, I don't want to spoil you too much, but you have to think. What are the devices that you can install that can tell the passenger that, oh, the door is open or the door is closed? Okay, so you have to think and propose suitable indicator for this. And then finally, in addition, the door should also be closed at control speed. So means the door close maksudnya close means cylinder retract. So the retraction speed must be controlled. So you have to consider using one specific device that can control the speed of the piston. What is the device? I don't want to tell you. You have to refer to the notes. But I can tell you it's one of the valves that we have in hydraulic and in pneumatic system. So you have to choose the correct valve that can be used, that will have influence in the speed of the cylinder when it is retracting. Okay, and then while the door opening, the door should take place at full speed. Okay, so this is different. When the door close, you have to control the speed, means it's slow. And then when the door open, there should be no speed limit, means that there will be a free flow to the cylinder and the cylinder will extend. Okay, cylinder will extend at a full speed. So you have to modify this pneumatic circuit. So you have to add something before the cylinder in order to control the speed of the cylinder, whether during retraction or during extension. All right. So you can read again this situation again and again until you can extract all the information needed before you start proposing your design. Okay, so the things that you have to do: A, by using fluid sim, you have to design an upgraded pneumatic circuit along with the corresponding electrical circuit. Okay, so first, this pneumatic circuit you have to upgrade according to the new requirement. At the same time, you have to also propose a new electrical circuit. Okay, together with all the things, push button, relay, especially this sensor. Okay, because you have to add the sensor in this electrical circuit. So this electrical circuit will be used to control the movement of the valve and also the movement of the cylinder. So you can choose any kind of sensor that can be used to detect passenger, but I understand that in fluid sim they don't have all the symbol for any type of sensor. Let's say you choose sensor A. I don't want to give you any example, otherwise you will know. But you can make a research. There are so many different types of sensor that can be used to detect human presence. Okay, so let's say you choose sensor A, but the symbol for sensor A is not available in fluid sim. So what you can do, you can represent the sensor with limit switch symbol. But you have to clearly explain in your report that the limit switch is just it's not that you are using limit switch in the real life, but you just represent it with for the specific sensor that you are going to choose for detecting the presence of the human. You can either use a limit switch, or maybe you can also use just a push button to represent the sensor, because for the push button then you have to press manually lah. Okay, because normally for the sensor will detect automatically, but if you represent with a switch during the simulation you have to press manually. But you can tell that, assume that this push button is actually a sensor. It's just that you cannot get the symbol of the sensor in your simulation. So after you are done with your simulation, when everything is running well as what you expect, then you have to record the simulation using Bandicam software or any other screen recording apps in your PC, and then upload the simulation video in either in YouTube or OneDrive, and then you have to provide the link for the recorded video in your report so that the examiner can check the simulation whether it's working or not. Also, in your discussion, you have to explain how the system works from the beginning until the end. Okay. So what happened when the push button is pressed, and then what happened to the cylinder, what happened to the valve, what happened to the relay. So you have to explain in detail. And finally, if the design is to be realized in the real world, you have to show calculation on how to determine the piston size with respect to the load involved. So you have to know, you can assume how much is the weight of the door, because the door is the one that is attached to the load of the cylinder. So if you know the weight of the door, you should apply the Pascal law. Because you need to determine the piston size. So you want to know you know that pressure equal to F divided by A. Okay. So you should assume how much pressure that you want to apply, and then how much force. Force is the weight of the door. Okay, so from here you can predict how big is the area of the piston, which is F divided by B. So this value and this value you can choose, because this is an open-ended question. You can choose, but it should be reasonable lah. How much is the weight of the door and how much pressure, the operating pressure that you are going to use to operate your system. Okay. So that's for task number 1. All right. For electro-pneumatic. Why do we call this electro-pneumatic? Because you have to draw pneumatic circuit and you have to draw the electrical circuit. So this system will be this one lah, nampak tak? Electro-pneumatic. The pneumatic system will be controlled by the electrical circuit. So that's task number 1. And task number 2, you are going to design electro-hydraulics, which is this one. Okay, you have a hydraulic clamp. Okay, same strategy. When you have this kind of question, you have to read the situation properly and try to you have to read the question properly and then try to extract all the information which are actually the requirement that you have to fulfill for your electro-hydraulic circuit. All right. Okay, let's just go through quickly. So you have okay, you have a cylinder here. Okay, this is your cylinder. And this cylinder is the one that acting on whether to perform the clamping process. Okay. And bear in mind that the drill part is not, I mean, the hydraulic system is only on the clamping mechanism, not on the drill mechanism. The drill, I don't know, maybe they use motor or they use whatever, but you are not controlling the movement of the drill tool down and up by using hydraulic. No, only the clamp. That's why we name this as hydraulic clamp. Okay, that one must be clear, because I don't want you to also design because there is no cylinder on the drill side, only on the clamp. All right, so the workpiece in figure 2 is to be firmly clamped during a drilling process. Of course, when you want to drill a workpiece, you have to make sure that the workpiece is firmly clamped. Okay, the clamp is to be operated by using double acting cylinder. All right, this is important requirement. Of course, you have to use cylinder, but in this case, it specifies that you have to use double acting cylinder. For the cylinder to extend, a workpiece must be first present or detected in the fixture. Okay. First, you have to understand the mechanism. If the cylinder extend, which is this direction, okay, extend, it means that the clamp will be on. I mean, like it will start to clamp. If the cylinder retract, which is go this direction, retract, this is actually unclamp. I hope you can imagine from this mechanism here. When it's extend, this one will clamp the workpiece, and then when retract, the workpiece will be released by the clamp. Okay, so in order for you to extend the cylinder, or in order for you to clamp, first there must be something, a sensor that can detect the presence of the workpiece here. Okay. Not only that, either one of two push buttons also should be actuated. Okay. So again, you have the term "and" here. So what logic it will be? Okay. So first condition, the workpiece must be detected by the sensor, and then the second condition is, and either one of the two push buttons should be actuated. Okay, and one more important thing, however, in FleetSim, you may assume the sensor to be at the retracted point. Okay, the sensor to detect workpiece, you cannot simply represent in your circuit, because this sensor is not part of the circuit, right? Because this is external sensor. So what you can do, you can in FleetSim, when you have cylinder, you can assume that this sensor is the one located at the retracted point, S1. So this is the same as this sensor. All right. So once this condition means when the sensor detect the workpiece and then one of the push button is actuated, then the cylinder should extend slowly. All right, this is also important. Slowly with an adjustable speed. So when you have this, you have to know what device you have to use. in your hydraulic circuit before the cylinder. What device needs to be used? Also something similar with this one just now. All right. And then for safety reason, during the drilling process, the workpiece must not be unclamped. So when the drill is already down here, there's no way you can unclamp. Otherwise, it will be dangerous, right? So just when the drilling tool returns to its uppermost position, which is after 1 minute of drilling process, then the workpiece can be unclamped by retracting the cylinder. So only when the drill tool is only back to the upper position, then you can unclamp. But again, in real, there should be another sensor here lah to detect that the drilling tool is already here. But again, we cannot. I don't know whether if you can include this sensor in your electrical circuit. Maybe you can represent with a switch, same like this one. Okay, represent by a limit switch or whatever. Or this statement also tell you that the drilling process will take place for 1 minute. Means after 1 minute, the drill tool will return back to this position after 1 minute. So here, when you know the time, there should be one device that you can use which is sensitive to time. I don't want to tell you what, but you should make a research and you should find there is one device that will only trigger when the time has already come. Okay, so maybe some of you have already know it, but yeah, I don't want to tell what device is it now. Okay, so then the workpiece can be unclamped by retracting the cylinder. So, and then finally the unclamping speed should be at maximum. Only during extend slow, but unclamping maximum. So same instruction, A, B, C, D, same like the previous task. Okay, so I think I have given you a bit, I think it should be enough for you, even though that actually you have to read the question on your own and try to discuss among your group what are the requirements. But this video is intended to make your life easier because we understand that in your lecture, BMCG 3643, for those who are going to do this lab 2 first in week 3, you might not learn about most of the components yet in the MCG 3640 lecture. So that's why I took this initiative to make a briefing with some more useful information for you to be easier to make you easier to design your proper system. But for the rest, you have to make your own research, or you can get back to me. Just ask me which part that you do not understand. Okay, so that's all. Thank you for watching, and all the best with for task number 1, task number 2, and also for the rest of the tasks in lab number 2. All right, thank you.